Hi, everyone. Thank you for having me. My name is Raul. I'm here today to talk to you about my journey as a data scientist and the most important lessons I've learned in building a career in data science. Before we dive in, there we go. Before we dive in, here are the topics I will be talking about. First, I will briefly go over my background. Then I will talk about the lessons I learned working as a data scientist in a small company. Then I'll move on to how my data science practice changed when working in a bigger company within a team of data scientists. Later, I will touch on the subject of imposter syndrome and how I managed this over the last few years. And then I will dive into a couple of case studies, some closing remarks on the practice of data science in the long run. So a little bit about me. I'm currently working as a data scientist at a tech called Confio. At Confio, I built and deploy loan origination models tailored for growing sectors of prospective clients. These models are responsible for the allocation of over half of the company's portfolio. I most recently constructed a behavior model for call center optimization, where we've already managed to improve contact rates by 10% in the first iteration. To provide a little context, Confio is Mexico's #1 fintech. Over the past 6 years, the fintech scene in Mexico has boomed and has become one of Latin America's tech hubs along with Brazil. Heavy investing in fintechs has transformed the industry over the past couple of years with players like SoftBank, Goldman Sachs, Credit Suisse, backing numerous Mexican startups. And most recently, Confio closed a Series D funding round with SoftBank for 100 million. And just a few months before, we closed another financing round with Goldman for another 100 million. Previous to Confio, I was the lead data scientist at a small financial firm called Laudex. For context, Laudex is a small financial institution in Mexico and one of the only student loan providers in the country. We were only 2 people in the data team by the time I left. At Laudex, I deployed another loan origination model. In this case, it was the main origination model for the company. And I later built the company's first central data warehouse on Google Cloud using SQL and Python data pipelines. And I also introduced BI tools to allow near real-time monitoring of approval rates and other KPIs. During my time of attending the NYC Data Science Academy 3-month bootcamp. And well, long story short, I got there once I had maxed out my technical skill set on the job and required more advanced programming language to truly help the company take the next step into becoming a leading fintech in Mexico. And most recently, I also finished a part-time data at SoftBank. So moving on to my experience working in a small company, I wanted to share with you a phrase that might come up in this context. Okay, so we want to do data science. This can be a two-faced sentence in the way that it may seem the company knows what they want, how to use it, and who they need. And more often than not, they don't know exactly what it is, what it's for, or who to hire. So if you find yourself in this position, do not despair. It's important for you to assume to a certain degree the role of data evangelist. Educate, otherwise the conversation will never move forward. So what to expect? What to expect when working in a small company? Expect starting from scratch. You will find this situation to be surprisingly common. For example, many aspects of banking and most investment funds are still run on spreadsheets. In this situation, automation will become your #1 priority. Being the only data person in the company is tricky. You will be expected to be an expert at everything data or code related. I found this after feeling overwhelming and disoriented, that a good starting point is to break down the most important deliverables in the company. understanding these deliverables and deconstructing them until you can lay out the most important data sources and data processing steps, and keep working your way down on the pyramid of needs. And once you reach the bottom, that is knowing how the data is collected and how the data is stored, you can begin to work on a vertical cross-section of the pyramid and grow by planning your projects so that you can iterate horizontally along the pyramid. Project planning practices like these are important for two reasons. They lead you to build something that you can get working end to end. And at this point, what have you gained? You've gained automation. And the second point is by extracting the data, cleaning and processing it and delivering it, you will bag a quick and easy win early on. As a first data scientist, you will be expected to record wins along the way towards deploying your first data model. So moving on to the data flow, a reliable data flow will be the cornerstone of the productivity of any data team, and it's a foundational part of the pyramid. A reliable data flow will empower you to swiftly tackle a variety of problems. This is, in the end, what makes the difference between a data science team that will thrive in the company or a team that will struggle to keep up. Now, data visualization is often overlooked, and it will prove to be one of your most important tools in your data science toolkit. Good data visualization is about practice in the end. An exercise I would often do before going to a meeting with the CFO or CEO or another head of the team inside the company. What I would do is plot something and ask myself questions that may arise among the viewers. Make adjustments to the plot and then ask those same questions to see how well the graph addresses the same questions. Think of data visualization as your tool to communicate the value of your work. It makes a huge difference for non-technical people to see the right graph. Ultimately, it is key for communicating and selling your work outside of your team. Now, when it comes to machine learning, which may not be the priority at the beginning, when you get to machine learning, always start with a stupid model. Most problems don't need a neural net to get a viable solution into production. As we mentioned before, get something working end to end, iterate, learn, and evaluate. If a more complex model is the next logical step, or if you should rather just work the data differently. You will find that most solutions can be deployed once 80–90% of the problem has been solved. Spending time and resources to get that extra 10% will not be the data science problem, but rather a management problem. So on a final note, just real quick, I'm gonna turn off my camera just to fix the audio issues. Let's see if that's better. Okay, so on a final note, you stations like pro. I actually wrote an entire post dedicated on this point. The thing is, many people think data science is like magic. You are the magician. So it's important for you to manage expectations so that you can deliver on time and avoid drowning in workload and dragging deadlines. Okay, so hopefully the audio issues are a little bit better now. So moving on to my experience working in a bigger company, in a medium-sized company, growing into a data science team. Working at Confio, I've had the opportunity to work in a big data science team, and we're around 15 data scientists at the moment. And well, before we dive in, I would like to present you with a couple of ideas that will come together towards the end of the talk. The first one, working in a team of data scientists is a very different experience than working independently. In a team, saying I only build models is a moral equivalent of licking the frosting off all the cupcakes. And there's more to data science than just the frosting. The second idea is this. A successful algorithm can have impact on a massive scale. YouTube's recommendation algorithm is responsible for over 70% of the time spent on the platform. This makes it one of the most successful algorithms in the world. And such successful algorithms do not spawn out of thin air or come to you in a eureka moment. They are consequence of an accumulation of knowledge, a cross-section of skills, and a combination of tools. A combination that is only possible along a sufficiently long time span. In practice, the team's ultimate purpose is to create an environment where data science can thrive to the point where the team can contribute to the business in the same scale as YouTube's algorithm. So taking a closer look at these bullet points, you might have noticed I chose to use the word imagine on the left side. This is because these points are rarely perfect in any data science team. They are actually what the team needs to thrive in the company. So beginning with model documentation. Model documentation includes any important EDA findings, any relevant plots that might have driven key decisions in feature engineering or target feature definition. It must also record performance metrics to use as benchmark when exploring more complex models, such as boosting algorithms. Then code repos are fully commented. Comment your code. This won't be the last time you hear this. I'm sure most of you have heard this before. This will be one of the most important habits you can make. People will want to work with you, even if your code isn't the most efficient code. When someone finds your code somewhere, you'll instantly make a good impression. Regarding the data, I think most people might agree with me when I say the bigger the company, the bigger the data will be a pain in the ass. I have this little voice in my head that always says, more data, more problems. And having databases laid out in some way is extremely helpful for this. Database schemas are usually the data or engineering team's responsibility. However, as a data scientist, it's good practice to describe where your data comes from. When exploring the data tables, take notes on what you find and confirm with data people or engineers what the data you're looking at is. Confirm with data people or engineers if the data you're looking at is what you think it is. Sketch or describe how you got your data and include any relevant joins or filters that you used. In the end, you should be able to explain what your training sample contains to non-technical people. Then moving on to deployment guidelines. These may just be some simple notes on the cloud services you use to deploy your model, along with a few key deployment dates. But you can go further than that and document how you must structure your code to send your model into production swiftly. Being in a team, you will be pushing for standardization and improvement of deployment strategies within your team. And finally, model monitoring. This is something that is really easily overlooked. However, it's a crucial aspect for the data science cycle to come full circle. Firstly, monitoring will allow you to quickly identify if your model is seeing the data you expect it to see, and therefore making the decisions you expect it to make. Equally as important, it sets you up for a general overview of the data used in your model. This is paramount when planning to iterate new versions of the model in the future. You or any other data scientist will be able to observe feature shifts or model biases and correct them in the next iteration. In the long run, this is how knowledge transcends the current model. It's how the knowledge transcends the current model iteration, and it's how the team retains knowledge gained from each data science cycle. Now, on an individual level, the best thing you can do is to elevate your personal working standards on these points, and to do this in time so that you can make a habit out of it. And if you do this in time, you will be the example to follow within your team. Okay, so moving on to imposter syndrome. Data science can be prime ground for insecurities to flourish. It's a new field. People are still figuring out what it is. There are different definitions on what it is. There may be a certain degree of confusion as to what you should know. It's also a combination of several fields that are sufficiently deep by themselves already. So it's reasonable for anyone to be lacking knowledge from any one of them individually. And it's also in constant expansion due to cheaper computational power and a lot of open source projects that makes data science widely accessible. So there's increasingly more people contributing and learning in the industry. This makes data science evolution very healthy, but it also makes it really fast, and so it's important to stay up to date. So okay, everyone in data science, everyone's data science practice is a work in progress. Everyone is learning on the job. Get used to Googling anything and everything. Be comfortable with the fact that you will never be able to learn everything. That's something really difficult to accept, and I may be struggling for that for a very long time, but it's important also to accept that you can contribute in ways no one else can. My advice is for you to get yourself into the data science community. This is applicable for people working on their own as well as people working in big teams. So for starters, Twitter is your new best friend. Tailor your Twitter for this new phase in your career, and the benefits will be twofold. Firstly, you will stay informed on the latest trends, and secondly, the content you see can serve as a source of inspiration for your work. First-hand exposure on what data scientists are doing allows you to truly see that everyone is learning on the job, and that helps avoid imposter syndrome. Find the head data scientists at companies you admire and follow them. These are real-life data scientists tweeting about what they're working on and the problems they're facing. Sometimes they pose questions and offer debates on data science topics, and they often share elegant solutions they found on fancy visualizations that you can maybe replicate. Finally, it even gives you the opportunity to interact and participate in the community. Secondly, open a Medium account. There you can find a variety of posts related to data science. You can find some simple introduction to a certain topic or steps on how to get started with something related to the cloud, for example. There you can find also solutions to highly technical problems and solutions with very detailed code. I would recommend you follow Towards Data Science and other crowd-generated content accounts. But you can also find sites for entire engineering teams like the Airbnb Data Science blog and the Square Technical blog. Then there's cheat sheets. So I would recommend that you save the PDFs that have come in handy at least a couple of times. These are useful when you are faced with new problems or have to explore data transformations or new plots, for example. And they are also good for getting to know a particular library. Then there's the personal cheat sheets that you create for yourself. So these are there so that you don't have to rewrite old solutions again and again. This will serve as your personal toolbox to jumpstart any project that comes your way. A good rule of thumb is if you have written the same code 3 times, write it as a function and save it in your cheat sheet. Personally, this was great advice for me to feel armed and ready to take on new projects. It also leads you to overviewing the content you've learned and organizing it into clean and in a concise format. And finally, a couple of good newsletters. Like KD Nuggets, these newsletters are pretty good on getting the skim on new trends and events in the field, especially when Twitter becomes too overwhelming. Newsletters offer nicely condensed content. Okay, so moving on to the first case study. I recently worked on a loan origination model for SME clients, small and medium enterprise clients. This was at Confio, so the project was the model had to determine who is creditworthy. And as usual in loan origination problems, this was an imbalanced classification problem. So in the origination stage at Confio, we have a significant advantage over other more traditional financial institutions due to the amount of data we collect. We look at huge amounts of data points per customer. Credit application data containing information on economic activity and also includes textual data on the purpose of the loan. Invoice data that allows us to analyze the company's cash flows and client-supplier networks. And finally, enterprise and shareholder credit history. The new version of this model had to incorporate two new data sources, namely the annual tax statements that we could find declared by the clients every year, and data on the company's payroll. And so during the feature engineering phase of the project, I focused on extracting more information from the invoice data. We had vast amounts of data, very rich data that was underexploited. So I found it might be a good opportunity to work something out of this. And for this, I experimented with a concept I read years ago in a research paper that explored emotional story arcs in novels. The researchers would plot a time series of the sentiment of the text of thousands of books and test different algorithms to find if there were any predominant shapes in these time series that could be considered as foundational story arcs. One of the algorithms they used was PCA, and they found that the most common emotional trajectories in their data set of novels. For example, they found one of the most common story arcs would be one that begins happy, then drops down in the middle to sad, and then finishes up happy again. Another one they found, they named the tragedy, a story that would begin happy and end sad. I took their idea and used it on thousands of cash flow time series for our clients for the months leading up to the credit application. In the end, final 5 features ended up in the final model that is in production today, which were a product of this experiment. So during modeling, we had periodic meetings between the senior members of the data science team, where we bounced around ideas on how the model was interpreting the data and if it made sense for some features to be as relevant as the metrics indicated. Then when choosing the supervised learning algorithms for loan origination problems, interpretability is very important. So I wanted to stick with linear models in this case. However, I was having trouble getting performance metrics that showed a significant improvement compared to the previous version of the model. So just to see how it will perform, I tried fitting an X, but it severely overfit the data. Specifically, the accuracy on the training set was close to 99%, which is uncanny, compared to the test set, which only had an accuracy of 40%. So there was a huge generalization error, and so in the end, we're sticking with an elastic net, which produced similar results on the test set, around 38% accuracy, but with much less generalization error. The accuracy on the training set was 47%. So the most important lessons I learned from this project, it's important to discuss any EDA findings. Reach out to someone familiar with the problem or the data that would have been solved if we had confirmed some findings with people in other teams. Okay, I'm going to pause a little bit. Let me see what we can do. Just 1 second. A little bit. Let me see what we can do. Okay. I hope this is better. Please let me guys know. Okay. Please let me guys know if there's any choppy audio, and I can repeat the statements so that nothing important gets lost. Okay, so I was talking about the lessons I learned from this project. Firstly, we found that discussing any EDA findings was really important. Reaching out to someone familiar with the data or with the problem turned out to be really valuable. We encountered problems with the data that would have been solved if we had confirmed some initial findings with key people in other teams. And secondly, code for your future self. This is something really important that I had to learn the hard way. When deploying the model, I found myself caught between writing code that will go into production and running the development code on new samples that would estimate cutoff points for more recent credit application data. My development code wasn't made for this, so I had to open 7 different notebooks, one for each data source, to compute features, and then another one to get the predictions. And lastly, monitor your model. Like I talked earlier, this is important for confirming that what we expected to see in the dev phase is equivalent to what we see in the production phase. We made the mistake of figuring this step out after we released the model to production, and as a result, we reacted really slowly when identifying some bugs in our code. Okay, so moving on to the second case study. On this project, we had to build a behavior model for the collections team to optimize call center efforts. In the first iteration, we focused on finding the best time of day to call a client. The greatest challenge with using supervised learning algorithms to solve customer behavior problems is to structure and process the data correctly. This is really important, something that I've learned with a lot of experience working in behavior models. If you manage to structure and process your data correctly, your model will perform much better than you expected. So in this case, we had many meetings with the collections team during the data extraction and processing phase to understand what kind of data we had to look at to solve the problem. These meetings were key for us to promptly confirm our findings in the data and to be aware of how the data was being collected. Early on, we realized that it would be important for us to test our model versus the current operation policy of the call center. So we scaled down our solution to a simpler version that we could quickly deploy into production so that we could confirm if our approach would work in real life and measure the effectiveness of the model. So the feature engineering. We started the feature engineering phase by creating a few features that we intuitively thought that would be useful and that made sense with what we discussed with the collections team. When dealing with customer behavior, however, there may well be many patterns that may be hidden in the data and the data scientists cannot see using the dimensions of the raw data. To help us understand all behaviors better, we use hierarchical clustering algorithm to discover hidden patterns in the client behavior, and we found a few things we hadn't considered initially. For example, we found a subset of clients that were still highly reachable, but were increasingly late on their payments. This turned out to be a critical segment that we wanted to contact before they defaulted further. And in this case, for the supervised learning algorithms, we consider that using tree-based algorithms would best adapt to our problem because we found many nonlinear relationships within the data. And in the end, we found gradient boosting algorithm produced the best results. So the lessons we learned in this project, I wrote down a few notes on the value that there was when we had the continuous contact with the collections team early on. We set up regular meetings, which were critical for us to deliver an MVP in time. And then in the production, operation, just one quick comment on the last point. So that continuous contact with the collections team, that was something I really pushed for after what I learned from the loan origination model with the previous case study. That was a critical lesson I learned, that I didn't want that to happen again. So in contrast with the development of the origination model, I set up regular meetings with the collections team to make sure we didn't run into the same speed bumps. And secondly, the in production operation, in this case, the MVP, the minimum viable product, taught us that the real challenge for this model would be to adapt it to the way the call center operates on a daily basis. There are many policies in place that the model must prove wrong, and we can do so by A/B testing before deploying fully into production. Feedback on the MVP will guide our decisions in the future on the cloud architecture we need for the model to successfully have the impact in the portfolio contact rates. Okay, so finally, to finish off the talk with a few closing remarks on your data science practice. Just a title slide. Okay, so you may have noticed paying attention to what is beyond the technical skills matters. In the end, you guys here today are people who have the capability to learn and learn quick. Technical skills are something that you can consolidate in courses offered by New York Data Science Academy or any other online courses, and you will always have the opportunity and energy to expand these skills. But in the long run, there are other things that need to come into play for you to get ahead. The first thing you can do is to stick to good habits we just talked about. Comment your code, document your findings, monitor your models, and make a habit out of these. Start from day one in the job. Stick to these habits so that doing them becomes effortless. Cross-pollinate. Accepting that you can learn from your fellow data scientists greatly expands your horizons and accelerates your learning. Get comfortable with collaborating with others, and you will be the first choice for the team when a project like YouTube's recommendation algorithm comes along. And when it does, you will be prepared for it. Get comfortable with the tech. This is a very good point that I've had to learn the hard way. The cloud may still seem elusive to some of you. It certainly did to me. But don't be afraid to ask questions to members of the engineering team. If you think you need it, get some training on cloud services. It can be a small crash course on YouTube or just a simple post on Medium. Understand the data flow. The most productive members in our team know what data is going to be needed before starting to work on the project. If you combine this with knowledge of tech and the cloud, you will be able to pump out solutions and proofs of concept faster than anyone in your team. And finally, to round things off, I think that the home run any data scientist should thrive for is to create an environment where you can bring good data science practices into equilibrium to the point where the team begins to contribute to the business at large scale. Thanks so much for your time. I think we will now move on to any questions you guys might have submitted.
Yeah, everyone, thank you. Sorry. Hello, everyone. I hope the audio is pretty good right now. Earlier, it was just some background noise. So that's a fantastic presentation from Raul. Thank you so much, Raul. Now we're going to take in some questions. If you have any questions, just drop them in the chat box. We received a few questions earlier. I'm going to send it over to Raul right now so he can answer them.
Okay, so some of the questions are coming in. Okay, the first one, let me see here. Okay, here we go. Question: are there any specific data scientists that you would recommend us to follow in addition to Towards Data Science and other cloud companies? Yeah, I think there's a data scientist called Chris Alban. He is the director of machine learning at Wikimedia and has a lot of experience as head data scientist at other companies. He even has a website where he uploads his machine learning flashcards, which are very helpful. I would also recommend um, anyone from the head from the head of the data science team at Airbnb. I have a few quotes from him written down, which are really helpful. And I think the two examples, Airbnb and Square, I find them to be like the leading tech teams with regards to data science. I've found a lot of posts that have been really helpful. Oh, and also the Netflix team creates a lot of very useful packages. For example, they produced Papermill, which is a tool that will help you automate the execution of your Jupyter notebooks. Okay, so there's another question around here. Second question. What is the best way to identify the niche specializations within your data science to pursue? Within data science to pursue? That's a really good question. So I think there's once you get yourself more reading technical data science blogs and some newsletters and some Twitter accounts, you'll start to notice that there's some really important challenges, for example, in computer vision and natural language processing, which those are the problems that are at the forefront of AI development, and those are where the latest developments and research in deep neural networks are being applied at. Those are niches that are really expanding quickly, and in our team, there's a few people that know that have really deep knowledge in neural nets and artificial intelligence, which really makes them an essential part to our team to be able to solve quite a few problems. For example, on image recognition for document identification, and also for natural language processing in real time for when we contact our clients. These skills have proved to be essential in the further development of the data science impact in the company. Okay, here's another question. From your experience, observation, how much coding experience is needed to be a successful start at your data science career? Okay, so that's a pretty good question. And I started out only knowing R at the beginning. I actually didn't have any formal training in R when I started out. I just had the opportunity to learn on the job and try out different solutions to different problems. And then I found that R was really inefficient to work with data and process data. So I started to look at Python to complement and make the data processing more efficient. And so I started to learn Python by myself, and then I got the opportunity to go to the NYC Data Science Academy. So I think that coding is a practice that once you get started, it really scales up and develops your skills further when you dedicate the time to it. So I think it's a really good practice and habit to get going early on. Okay. And here's another question. Could you talk a little bit about opportunities to move into data science roles, to product strategic leadership roles at tech companies? That's actually a really good question that I myself have been looking to answer for the last few years. So how to move to a more product strategic leadership role? I think it depends on your capacity to communicate with non-technical people, especially when there's some solutions that are very highly technical. If you can somehow relate and get on the same page as other stakeholders in the company to solve the problem, then you will be naturally pulled by these people closer to their product and strategic teams to well, start pumping out smarter products, data-driven solutions, because well, you're going to be able to bridge the gap between the technical people in the data science and engineering world and the non-technical people on the product and client-facing side of the business. So the more exposure you have with other stakeholders, end users of the data science products and the data science models, the more you will be able to communicate with them easily. And complementing that, I think also having a good deep knowledge and understanding of the tech, the cloud services that you might need, the architecture that a product might need to get something running fully automated and deliver the results in real time. That is really critical. And also understanding the data flow in the company, that takes a little bit more time and experience. Once you get working with the data slowly during a certain period of time, understanding the data and the quality of the data that the company has, that's really important to know if a product is viable and how the final extent the solution is going to have. So yeah, I think that's something people are still working on, and because data science is so new, I think people are just making the jump from being a highly technical data scientist into more strategically led positions in tech companies. Okay, so another question coming in is, how would you describe the difference between cybersecurity and database security, if any? Okay, so I'm not an expert in security and cybersecurity, but what I can tell you from the data science side is database security is really more about anonymizing the data of any clients that you may be working with. That is really important in the case of credit applications and loans. You're handling really sensitive data of the clients, especially here in Mexico, where you deal with invoices, for example. That is highly sensitive and private data of the clients that they sign off a privacy agreement for you to be looking at that data and analyzing it. So that's with regarding more database security. And when talking about cybersecurity, I think my expertise is even less. But the difference would be that cybersecurity would be having a safe connection, for example, with using VPNs, which is something very important in tech companies, to establish secure connections to the data servers and code repos, GitLab, and all of that. That is that is what cybersecurity entails, most differently from the database security. Okay, so I think we're coming to the last few questions. This one is, how can you perform data scientist work with just Excel, Access, and a knowledge of SQL? If not, what advantages do other programs or languages offer? That's really great. I think I actually, I think early data scientists started doing data science work in companies using just those tools, Excel and some knowledge of SQL. In the end, machine learning can be something as simple as a linear regression, which you can easily calculate in Excel, and you can pump out the beta coefficients of the model and place them inside the web page, and you can actually make like an automated decision, data-driven decision machine live on the website, and that would be considered machine learning. So I think it's totally viable, and I think at some point in my early stages, starting out to explore the data world, I think I started out as a data scientist that only did stuff in Excel. I actually got my SQL knowledge very later on, which now looking back was a great decision, because getting accessibility to the data is really important. It's foundational to being able to solve more complex problems. And in terms of advantages, I think working with Excel, if you're like a master at spreadsheets, and you have to be very organized to keep your Excel files manageable. I think Excel has the advantage that it's very user-friendly. It's very interpretable by other members in the company. It's very easy to show the work and the solutions you're working on, how a certain model works and consumes data. Sometimes when working with just the programming languages and the code, most people really get alienated when something is using code. So Excel has that advantage of working well with other members other non-technical members in the company. And well, I think the principal advantage of using other programs and programming languages would be that it makes your work reproducible. Do something really complex in Excel, you're probably only going to do that one time, and that's it. You may have it somewhat automated to be able to consume a little bit more rows in your database or a few parameter changes, but if you get an entirely new database, it's going to be very difficult for you to replicate your work. You're going to basically have to start from scratch again. And the thing with programming languages like R or Python is that your work will be extremely reproducible in the sense that you're going to be able to feed it many kinds of databases that your code can deal with, so that it becomes somewhat bulletproof, and you can use your same code to solve the same problem with different inputs and different data. Okay, and I think Terence is going to take over after this final question. As a data scientist, do you collaborate with your fellow team members, or do you work on your own? Does anyone work on your code, or do you program by yourself? And can you describe how that collaboration looks like for you? Okay, so these are a few questions. Let me just go for the first one. Do you collaborate with your fellow team members, or do you work on your own? That's a really good question, and that's something that in the team, it's something that we've had to constantly work on. Because as a data scientist, it's very easy to work on your own and not have anybody interfere with your code and with your EDA analyses. So learning how to use GitHub and GitLab, that's really helpful because it allows the data scientists to collaborate on the same code, develop different features for the same data. So that's a really useful tool. However, it's usually not enough. You have to be in constant communication when working on the same data with other data scientists. So bouncing around ideas on what you found inside the data sets, any cool plots or relevant plots that you found that are helpful for you to understand how a certain behavior relates to another column inside the data set. So it's very easy to seal yourself into your own little data science bubble and work by yourself. So collaborating with the other team members, it takes energy, but in the end, I think it's much more powerful because, as like I mentioned before, other data scientists have other skill sets which complement each other in the end. So bigger things can be created. There's more power in a team than by yourself. And well, yeah, I think I kind of answered the second part, but so describing how collaboration looks like in our team. Well, there's quite a few model scrums that we like to set up so that we can bounce around the ideas and discuss how we're gonna do the future steps of the project. So if we're seeing a certain problem with the data, we might have to check if we can make a deployment in real time, and if we can use a certain cloud service on AWS to deliver the predictions, or if the data that we're consuming actually has a lag that some of the other team members working on the data hadn't noticed. So I think there's a lot of opportunity in data science for collaboration that I'm sure most teams haven't still figured it out entirely. So that's my take on the collaboration in data science teams. Thank you everybody for the questions. Those were great questions. Thanks so much for your time.